All right, welcome everybody to week 3, day 1. We're going to be talking about error checking in the first half of class today. How to use if statements to make sure that your input is valid, that it is good, that it's not going to cause a plane crash or a train wreck or something like that, or an underflow or an overflow. And then we are going to move on the last little bit of lecture today to talk about for loops. So we're going to be moving on to the next major bullet point in the all-encompassing list of things you can do in computer science. So to begin with, we're going to start with some lab time. And this lab time is going to have you do a couple things. I'm just telling you almost what lines of code to type in, because this part isn't the thinky part. Make a variable of type int named grade, initialize it to 0. Basically, always init ints and doubles to 0. This is just a rule of thumb that, trust me, you want to do. A lot of students will just type like int x, and I do it sometimes just because I'm lazy, but don't be lazy. Be a diligent student. Every time you make an integer, initialize it to 0. Every time you make a double, initialize it to 0. Okay? Don't ever have an uninitialized integer or double. Just trust me on this. I'm speaking from a place of deep pain and experience here, having been burned many times by having uninitialized variables. Because if you have an uninitialized variable and you have an if statement using that variable, who knows what will happen? Because uninitialized variables can have literally any value. A lot of the times they'll have a value of 0, but not always. And that's not something that you ever want to hear from a computer program. It works most of the time. 90% of the time, the AED heart attack, paddles, they turn on 90% of the time. That's good, right? Like 90%'s an A, right? The bridge doesn't collapse 90% of the time. That's good. 9 out of 10 cars make it across without dying. That's good. Okay. So do you guys understand this? You're going to make a variable named grade, initialize it to 0. You're going to ask the user, please give me a grade from 0 to 100. You input it. And then you're going to have a set of else if statements. One thing to note, one new learning point for today, is if somebody types in something not an integer, you can check for that by doing an if not cn after the input. So if you do a cn into x and you say if not cn, then you'd be like, x doesn't exist yet, be like bad input. You do something like that. Okay. This is something you need to do on your current homework. If not cn checks for things like squirrel or like floating point numbers, things like that. So if the user types in their name when it was expecting a number, then it will cause an error. You check for an error like this. And then you can just print to the screen, bad input and quit. The reason why we print bad input and quit is because in C++, clearing a bad input from the input buffer is actually surprisingly difficult and tricky to get just right. So in your homework assignments, especially where you're at right now, if they do anything wrong, we detect it, which is good. Because a lot of professors will just not give their students bad input because it's too hard to handle. I just at least want you to detect it and to quit in case something goes wrong. Okay. So I'm going to give you lab time now. Based on the number they type in, print out their grade, and think about, this is kind of the main topic for today. Think about when you're going to print error to the screen. Okay, what kinds of situations, what kinds of things the user can type in that will cause error to be printed to the screen. Okay, lab time begins now. I'll give you 15 minutes. All right. And we're back. So make a variable of type int named grade, initialize it to 0. That's the line we're looking for there. Cn into grade. This here is going to check to see if they type in something like squirrel. Now, one thing I did want to mention is a lot of students wanted to just write this entire thing from start to finish. And don't do that. it's a really bad habit to get into, trying to write a lot of code at once without testing it. Honestly, I shouldn't even have these if statements in here. I was just doing that to just kind of demo some code for those of you that needed to remember the syntax for if statements. Realistically, I would have written about these 5 lines of code. Make a variable and put into it, check to see if there was a bad input, and then I'd probably throw in a little throwaway line like this, and then like quit. And then I would compile it, no errors, run it. I would type in 100, I get 100 back. I type in 50, I get 50 back. I type in squirrel, bad input, right? So you want to check your code constantly. You want to test your code constantly. You never want to write large amounts of code all at once. It is the single greatest trap for people in C/Sci 40 is they try writing their entire program all at once without compiling it. It's probably a little bit even more of a trap for you guys now because I've enabled a compiler. If you forget something, it'll give you an error, right? And so you can actually know that your code's going to compile. That doesn't mean your code's going to work right. And that's our topic for today is checking errors. And that's like a 2-pronged thing. First of all, there's errors that are going to come in from the user. You ask them for an integer, you ask them for a grade between 0 and 100, and then they type in something that's not an integer at all. That's a bad input. But also something a little bit more subtle. I should probably have the string here, right? Something a little bit more subtle is you're asking them for a number from 0 to 100, but I'm not checking to make sure that the number is between 0 and 100 currently, right? And so I should add in a check here to say, or if grade is less than 0, or if grade is over 100. These are all the different ways that it can go bad. Either the user types in something that's not a number at all, or they type in a number that is outside of the range that I'm asking for. And a lot of people just don't check that, right? Like, in fact, Mincarelli in his solution, if you typed in -10, it would say F, right? But can you get a -10% in a class? I guess actually maybe, but I'm not really sure how you do that. Can you get over 100% in a class? Yeah, with extra credit or something, but very specifically, we're asking for the user to type in a number from 0 to 100 here. So it's very, very important that you vet the input, V-E-T. Vet it. Vet the input. Has nothing to do with veterinary science. Okay? This means that you make sure that if you're asking for a number between 0 and 100 inclusive, that you get a number between 0 and 100 inclusive. Okay? Not -10, not 110, not squirrel. You're getting an integer between 0 and 100. This is how you do it. This is our topic for today. Okay? And then you compile it, you test it, you try all the different possibilities you can think of. Right? So what if we tried a floating point number? Is a floating point number a integer? What do you guys think? Do you think this is going to work? It's not an integer, right? So we get bad input. Get an error. And obviously, is a squirrel an integer? If we type in a string, is this an integer? What do you guys think? Nope. Okay. What other things could cause a problem? What about -0? Is -0 an integer? Yeah. Somehow. And one second. What do you guys think? What else could cause a bad input? What about 1.5? Is that an integer? It is kind of. So this is a little edge case that you guys need to know about. So if you try putting 1.5 into a float, or if you try putting 100.123 into a float, the way that it works is that it starts reading one character at a time. The 1, the 0, the 0. If the first digit if the first letter is a digit, once we get that 1, no error is going to occur. Guaranteed. Because what happens is it keeps reading numbers 1, 2, 3. Then we get to a number, the dot, that is not a integer, and it stops. And so what is left in the input buffer, if we were to let's say make a string s and cn into s and output the string afterwards. If we type in 123.456, what do I do here? Cn grade. Oh, the number's too big. Right. 100.123456. Then what happens is the 100 goes into the integer, and then the dot 1, 2, 3, 4, 5, 6 are left in what's called the input buffer. And that data is going to be read in for the next thing we read in. Okay, so if I type in 12.789, the 12 goes into the integer, and then the 0.7878789, whatever, is left in the input buffer for the next thing that we read. And this can cause a problem if you have something like grade and, I don't know, age or something like that. So if we try reading in age here, always initialize your variables to 0. So if we read in 2 integers and we read in 10 and 20, we get 10 and 20. But if we read in like 10.1, then you can see the 0.1 did not get read in properly. And in fact, if we check for an error here, if not cn, the 0.1 or whatever is going to cause an error, a failure on this line. And so every time you do a cn statement, you should, especially for like reading integers, because there's so many different ways you can fail when entering an integer. Basically, every time you do a cn, it's just probably a good habit to be like, if not cn, die, right? Or in this case, just cout. I can just y2y and p, and there we go. Okay. So if we type in 10.5, we get bad input. If we type in 1020, it's good. Type in 30 squirrel, we get bad input. 30 squirrel, get bad input. Okay, you guys understand? So basically every time you do a cn, and this is going to be true for calculator, right? Like a large number of the input tests on our homework assignments are looking for errors. Okay, they're looking for the cat walking on your keyboard when you're expecting a grade. Okay, and that's deliberate. It's because I really want students in this class and, well, all of my classes to think about all the different ways things can break, because there's a lot of ways things can break, and you would be surprised how many computer science programs just allow bad input because the programmers didn't think to themselves like, well, what if somebody typed in a negative age? What if somebody typed in a negative height? You know, can a person have a negative height? You guys tell me. Does it make sense if somebody says, I am negative 5 feet tall? You know, like, does that just mean you're laying the other way on the table? You know what I mean? Like, you know, you're supposed to put your feet here and your head here, and they measure you, and you're backwards. You're still 5 feet tall, right? Like what's your age? Negative 30. This is 30 years before I was born. Like, you know, unless you're Merlin or something, like, it just is not one of those things that should allow a negative value. And so there's a lot of bugs that have come about through people just not handling negatives properly. People assume that wind speed can't be negative, and that causes problems. If there's a huge gust of wind on an avionics system on a plane, it causes the system to go into a fault state. It causes the crash of an Airbus going from Brazil to Portugal, I think. The internet went down once because somebody published a negative duration route. So like all the ISPs use what's called BGP, Border Gateway Protocol. And somebody published a route that had a negative time cost. And so what happened was the shortest route for, somebody sending a packet from, let's say, London to like Birmingham in England, the shortest route would be going all the way over to America, through the cornfield where this guy had published a negative route, back and forth an infinite number of times, and then over to Birmingham. And so the entire internet tried routing themselves through this one guy's cornfield. And the entire internet went down like 20-ish years ago because a person fat-fingered and typed in a negative number where it should have been a positive number. Now, should the algorithm allow negative numbers? No. Do they allow negative numbers now? No. Did they then? Yes. And so all it took was one person on the internet mistyping something on, one keystroke, and it took out the entire internet because they, well, who would type in a negative number? Well, are you confident that every person ever is going to type a positive number in here? No? Then you should probably vet it. Are you guys with me on this? Like, every time the user types in something, you need to double check what they typed in. All right? Your users are either stupid or malicious, either deliberately or unintentionally. Okay? That includes programs you write for yourself. Let me show you a program that I wrote. I am the only user that uses this program. Just me, nobody else. And 90% of the code is me doing error checking to make sure that I don't screw up. Okay? So this is a shell script. This is not C++, but this is the code that I use to deploy your homework. So for example, if I said sudo deploy homework, csci40, calculator, no clobber, this will push out copies of the homework to all the students in csci40. And if they didn't have it before, they have it now. No clobber means don't overwrite their files. If, however, I typed in overwrite like this, it will overwrite all of your homework assignments. So if I just hit enter like this, it's going to overwrite all of the code in your directory. I'm kidding. Okay. So, and if I don't type in anything, then it will, where do we go? Then it will ask, do you wish to overwrite this guy's file? No. Do you wish to overwrite this file? No. And it's going to go through every single student. So this is a shell script that I use to push out copies of my homework. And so let's take a look at this. I will show you how much vetting I do. This is a program I am literally the only person that ever runs on this server. Okay? And so I first check to see, do I have root access? If I don't, I can't copy things to your thing. That's me putting the sudo there. Sudo gives me root access on the server. If any of you guys try using sudo, it'll report you to the system administrator, which is me. And then I ignore it. But if I try running this without sudo, I don't have permissions. I'm just a regular user on the system. If I run it without permissions, I can't copy things into your directory. I have to run it using super user, i.e. root permissions, to copy a file from one account to another. Same thing for collecting homework. I collect it using root, and then when I compile it and run it, I sudo as you. I run the program as you. I don't run it as me, because if I ran your code as me, then you could write code that said delete all the files on the server. And that would be bad. So if you try deleting all the files of the server as your homework submission, it will erase your files and nobody else's, just so you know. So when I try running it without root privileges, it says this script must be run as root, and then it prints to me sudo deploy homework, csci40, calculator. Literally the words that I just typed in, it repeats back to me. Very nice, right? So that is these things here. These are the command line parameters, and then it quits. If I don't type in the right number of command line parameters, it gives me a nice paragraph. Here's how you run it. Idiot, you, person who wrote it, here's how you wrote, and sometimes I forget, like, what is the command? No clobber, override, what is it? And so I just run it, just like sudo deploy homework like this, just to see how to run it. And then I read it, I'm like, okay, all right, it's overwrite, not override. Like sometimes I'll spell it as override because I misremember it, And then it tells me, if overwrite, it forces the file copies. If no clobber, it forces it not to copy. And so this is just for me, because it'd be really bad if I accidentally overwrote all of your homework by accident. You know what I mean? I think you guys would appreciate it, me not doing that. All right, guys, sorry, you have to do the homework again. I then check to see if the class name has any letters or anything that is not a letter or number, I should say. So the class name here which is CSI 40 underscore FA23. If that had any special characters in it, like semicolons and things like that, that could break and do injection attacks, who would be doing the injection attack? Me. Deliberately? Probably not, because I could just do whatever I want. But if I accidentally put a semicolon in there, all hell could break loose, because I'm running the script as root. It would be really bad. I could just completely hose the server. And so I make sure that I don't fat finger a semicolon into there. And I check, does this name have anything that's not a digit or a lowercase or an underscore? If there is, it'll bail out. If the homework name has anything that's not a letter, number, or underscore, this is a different way of doing the same thing, I think, or hyphen, then I bail out. If the class name doesn't exist, I bail out. If the homework does not exist, I bail out. This is actual code. Then I print deploying homework. Yay, actual code finally. And then I say for every student in the file, and again, I am going through this file and removing all special characters so that I don't accidentally injection attack myself by having a semicolon somewhere in some student's username by accident. And I then check to make sure the student exists, because I don't want to copy things to students that don't exist. That would be a problem. If the student doesn't exist, I print a message. By the way, Escobar doesn't exist. Please create him first. And so that happens, right? Like sometimes I'll delete a student, but they're in another class, and I don't delete them off that class roster. Then when I try deploying the homework, it's like, hey, by the way, this person's no longer on the server. I'm like, oh, yeah, thank you. Me, right? Because think about it. Like if you've got multiple classes and you're collecting and pushing out things, and students are adding and students are dropping, you can get into a situation where they're in one class and they're not in another, and they get deleted off the server. And so I double check everything that could go wrong. I check to make sure that the student is not a system account. System accounts have user IDs of below 1,000. And so I'm 1,000. I'm the first user on the system. All the important accounts are below 1,000. So if you ever try copying things to a system account, no, it doesn't allow it. And then here we finally get to the actual one line of code that matters. So this copies the directory to yours. That's it. This is the entire payload. Okay. It just copies the folder into your directory. So for every student in the class, copy the directory over. And if it's overwrite, it forces the copy. If it's not, it asks you. If it's no clobber, it does not overwrite. That's the only difference there. And then I just mess with the permissions a little bit. I make sure that you own the file. That's what change ownership means. Chown means change ownership. You own the directory now, not me. You have read, write, execute permissions. I don't, or other people don't. More importantly, your students, your fellow students cannot see your directory. That's kind of important. If I had a system user in here, I'd print an error. But this is basically the whole thing. So like all those checks are just to make sure that that one copy goes through without destroying my system. And then I clean up the permissions a little bit. And set any shell scripts and 8.outs to be executable. I do a little permissions things. I make sure that your directory is not world readable, so that people can't go into your directory and copy from you without your knowledge. But basically, yeah, it's like 1-ish lines of code or 2-ish lines of code out of the 110 actually do anything. Maybe 12 if you include the chown and chmod statements. So, no, not like the root directory. So when you run something as root, that is the super user. So if I become the super user, I can go into anyone's directory. I am the super user now, so I can go into Escobar's directory and see how much work he's gotten done on the calculator assignment. None. And I can delete this file. For example, I can take Nico's homework and just erase it like that. And there's nothing you can do about it. I have root access. Root access is super user access. So if you have heard of Bitwise, the fraudulent Fresno corporation, one of their offices was called Root Access Hackerspace, I think. Something like that. Maybe it was, I think it's Bitwise, right? root access hackerspace. Or maybe I'm confusing this with someone else. No, this is not Bitwise. Sorry, I apologize to the root access people. These people are amazing. They're not part of Bitwise. This is a really cool place. It's over in Figuren, I think. Like more like Fresno City College. It's like a block south of Fresno City College, and they've got just like a ton of like tools, and they have a laser cutter and soldering stations and stuff like that. It's a really cool place if you're into like. There's a lot of fiber arts people that do sewing. They have 3D printers. They have video games. It's a really cool place to hang out and get to know people. Anyhow, the point is, I have root access. As you see the little thing here, the prompt's a little different from what you're used to. I am root. Who am I? I am W. Kearney, but I'm root. I'm Groot? No, I am root. Okay. So that is the all-powerful root that you've seen in action now. And when I run something with sudo permissions, I run it as root. I really should have a password on this when I run it, but I'm lazy, so I don't. So if any of you get access to my computer here, you could erase the server. I guess. Don't do it, please. It'd be a pain. I have backups, but it'd be a pain. Okay. So vetting your work. Okay. Let's take a look at some of this stuff here. All right. So we output grades and grade. You have to type in a squirrel. Output bad input. You should probably quit at that point. You should probably quit because the grade's going to be 0 if they typed in a bad input. Grade usually gets set to 0, and then it'll give you an F. So it's going to say bad input and F at the same time. Probably you should return 0 or return 1. Return 1 means there's an error. Does the operating system do anything with it? No. Could it? Yes. Does it? No. So in general, return 0 means no error occurred, and return 1 or some other number means an error occurred. It's probably a good habit to get into, but as of right now, what difference does it make? Absolutely nothing. Okay. You should probably put a return 1 right here. Okay, so if grade is greater than or equal to 0 and grade is less than or equal to 100, if the grade's over 90, A, grades over 80, B, C, D, F. Okay, so this code is not handling the user not typing in a number between 0 and 100. Okay, so Hernandez, if the user typed in negative 50, for example, it would print nothing to the screen, right? Not bad input, just nothing. If they typed in 3000, it would print nothing to the screen. So you should probably have an else statement, like right here. Like if the grade is valid, do this. Otherwise, print out, hey, you typed in a number outside of the valid range. Try again tomorrow or something like that. Okay. But otherwise, very good. This is a habit you just have to get into, and it's a habit that will give you lots and lots of points on the homework, because we give a lot of points for checking for errors, checking for bad input. I think on the current homeworks, we give you the Declaration of Independence. We give you the top 25 animes, like when the user is trying to type in a no, don't do that. Don't do that. Just CNN to grade. Just CNN to grade. That inputs the grade. You're making random numbers here. Yeah. None of those rands should be there. Let's see here. Yeah, just CNN to grades like that. But honestly, like if you guys want to know a pro tip for all of my computer science classes, if you aren't going to do the homework assignment, one life hack you can do is just have your program print out bad input and quit, and you will probably get some points, because there's a lot of test cases where it's just bad right off the bat. It's not going to get all of the bad inputs, but it'll get you some. And so it really bugs me when I see a student getting a 0 in my homework assignments, because, like, bro, just type out, see out bad input and quit. You're going to get at least a few. You know, maybe you'll get like 5 out of 10 and you got an F still, but it's a high F. A high F is better than a low F, right? Like 5 points is 5 points. Like, it's pretty significant. And so, yeah, even if you don't do any of the homework assignment, if all you do is the error checking on assignment 3, the one you're going to be getting on Friday, if all you do is just the error checking and don't do any of it at all, the assignment for Friday, by the way, in honor of Nico adding my class. Nico is a longtime friend of mine. He has decided to finally buckle down and take computer science. Everybody give Nico a bunch of clap emoji on the chat channel. Nico and I took Japanese together 4 years ago. Yes, 4 years ago, almost to the day, we started Japanese together. And so in honor of Nico joining this class, our assignment for Friday is going to be translating Japanese. So we are going to be doing counting in Japanese. So for those of you watching the stream, Nico is saying why over and over again. So yeah, good times, good memories there from Japanese class. But something like 80% of the points on the Japanese one are just from bad cases. All the different ways that people can type in something bad, or warui, as we say in Japanese. And so if all you do is just like the bad, input checking, you will get like a B on the assignment, or something like that. Like I don't have the exact numbers, but it's really important. And the reason why I give so many points for error checking is because a lot of people just don't think about it. They just don't consider the fact, oh, somebody could type in a negative number. Somebody could type in 200 here. It's human nature to only think about the good possibilities and not think about the edge cases. What if they type in 0? What if they type in 100? Like here, we've got an edge case, right? I don't know if you guys see this. What if the user types in 90? Is 90 less than or equal to 90? Yes. Is 90 greater than or equal to 90? Yes. So 90 is actually going to trigger on both of these things. Now, these are else if blocks, so it's not going to matter. But this is technically, I would say, bad code, because the equals can never happen. Because if it's equal to 90, this one is going to pick it up and it's going to print A. This one is misleading. It looks like it should trigger on 90, but it doesn't, because this one it's going to pick it up. So the edge cases are like right on that fine line of an if statement, like right at the equals. Everything less than or equal to 90. Well, try it at 90, try it at 89, try it at 91, and see if it works. And when you test your code, like I said, write 3 or 4 lines of code at a time. Write 5 lines at a time, max. And you compile your code, you run your code, you test your code. You write a little bit, and a little bit, and a little bit, and you test it, and you test it, you test it, and you make sure that it works. And so the places where bugs occur right on those boundaries. So there's 3 things you test. You test good cases like 85 and 92. You test edge cases, which is like 100, 90, 80, 0, 101, 1. And then you test bad numbers, negative 50, negative 9,000, positive 5,000, right? So you test numbers across the range. You have to really pay attention to those boundary conditions on the if statements. And test a little bit above, a little bit below, and right on the boundary, and see if the numbers you're getting are correct. Okay, so if grades are greater than 9, okay, if grades are greater than or equal to 50 F, that is incorrect, right? An F is 0 to 59. Okay, so if you had typed in 40, like if you had tested this code and typed in like 40, you would have gotten bad input. But 40 is perfectly, like, I don't want to say it's a perfectly fine grade, because it's not a great grade, but it's not bad input. Like if the user types in, I got a 40% in the class, what is that? You shouldn't say bad input, right? But that's what this code's doing, right? And that's kind of the central thesis for what we're talking about today, which is it's really important to test your code, write incrementally, test your code, good, bad, edge case, and get good coverage over it to make sure it all works right. Let's look at one more. All right. And grade, always initialize your integers. Always initialize your integers. I know it's like 4 extra characters to type. I don't do it always myself when I'm being really lazy. But please, always, always, always initialize integers and doubles to 0. And floats and similar things. Okay. Strings you don't need to initialize, but ints and doubles, always trust me on this. Just trust me. Okay, so cout, please integrate it from 0 to 100. Cn grade. Okay, so if not Cn or grade less than 0 or grade, yeah, if grade is less than 0 or over 100, can't do that. So this is a very common mistake that new programmers make when working with if statements. You want to translate it like in English, right? If the grade is less than 0 or over 100. Sorry, it doesn't work that way. If you have an or, it has to have a Boolean expression on the left and a Boolean expression on the right. Greater than 100 is not a Boolean expression. So you would have to write grade greater than 100 on the right. Okay. Same thing here, same thing here, same thing here. Very common mistake. It's one of the most common bugs that I see in these kinds of things. Very common. Because people just want to translate English into code. But you have to say if the grade is greater than or equal to 80 and the grade, that's the missing part, and the grade is less than or equal to 89, then print out B. Okay. And then you weren't quite finished, but that's fine. I see the direction you're going. Looks good to me. Maybe we'll look at one more. Good. The indentation's a little... Oh, you don't have the closed curly brace here. Yeah, you're missing 2 closed curly braces. So another habit that you should get into, and in fact most IDEs will do this for you. I hate it when they do it because it screws up my workflow. But like if I'm going to write this if not Cn thing here, I write it like this: if not Cn, open bracket, and watch this. I hit return, close bracket. I do the open bracket and the close bracket at the same time. Because if you don't, then what happens is you get something like this, where you got the open bracket, and then you just start going. And this is also a sign to me that you're writing the whole thing all at once without compiling it, right? Because this would never compile without that closed bracket on there. Which is fine. Like, this is actually like a teachable... No, I'm not picking on you. Almost every student in the 12 o'clock class wrote everything without testing it and compiling it. Like, it's a thing that programmers do. And this is why I'm having a lecture. Like, just write a little bit at a time. Get 4 or 5 lines of code, compile it, test it, then write 4 or 5 more. Compile it, test it, run it. 4 or 5 more, compile it. It's like building a pearl, right? You start with a little grain of sand, and then you wrap a little mother of pearl around it, wrap a little mother of pearl around it, and you just keep building the pearl up. And you're testing it, and you're making it more and more beautiful as you go along. You don't try and make the whole thing all at once. I had a student, a very gifted student, but I gave a Pokemon assignment. He wrote the entire thing in one go without compiling it once or saving it once. And by the time he got around to like saving it and compiling it, like nothing worked. Like, how many missing curly braces did he have? Yes. Right. All of them. Like, you know what I mean? Like it's just like, okay, where do I put the missing semicolon? Like, I don't even know, dude. You got like 300 lines of code. Half of your for loops and things are missing curly braces. Like, I can't, like, this is just too much. You know, just go home tonight and just think about your life choices, you know? So yeah, again, I'm not picking on you. This is, I'm actually happy when I see, maybe happy is not the right word. It's like, I'm gleeful that, no, not at all. But it's very useful, you know, to see things like this. So again, when you get when you're making an if statement, open curly boy, close curly boy, then go to the middle. And one useful thing inside of Vim to go into the middle is to hit Shift O. Shift O opens the line above. O opens the line below, and it puts you into insert mode. So open curly brace, close curly brace, Shift O, that's my workflow. And then I write, you know, cout die error. Okay. So that is a habit. Also, I want all of you guys getting into is never leave your curly boys hanging, right? So I noticed that the closing brackets appear automatically in an else statement when doing the homework. Yeah, a lot of IDEs, a lot of text editors will automatically put the closing bracket for you for this reason. But it, like I said, it screws up my workflow because like I have, you know, basically muscle memory of like doing things, and like the extra characters in there, they if you type over them, like if you type over a closed parentheses with a parentheses, it eats it. But like if you backspace or something, like it screws up the number of characters. Like because I know I've got to go 4 characters to the right, and you know type this and type that, and when the thing's just throwing extra letters in my path, like it actually literally slows me down. And I'm somebody that is all about the efficiency, typing speed and coding speed and things like that. I used to do coding competitions, and you'd have to write 6 large-ish programs in 3 hours. And I never got 6 done, but I would get like 3 done, you know, which is pretty good. Not like University of St. Petersburg winning, you know, but yeah, doing 3 assignments in 3 assignments in 3 hours. Pretty reasonable. And it definitely made me a better programmer as a result of that. Okay. So, all right. If I were to finish this, if else, YY 4P 7 6 0 something like that. Let's see here. So if the number is between 90 and 100, we print out A. Else, if the number is over 80, we output B. Notice that I don't have to have a check for less than 90 here. Because if it's 90, it's already been 90 and above, it's been picked up by A. So all I have to do is this max and min on the first one. After that, the previous one is going to pick up the, like if they type in 95, it's not going to print B, C, D, or F, right? Because it's if, else, if, else, if, else, if. Only one of these is going to print. So if it's between 80 and 89, we get a B, 70 and 79, D, 16 and 69, nice D, 0 to 59, F. And if it's any value other than those picked up by this, no, that's wrong. This is wrong. So we type in 110. If we type in 110, then it's going to print out B. So let's. Oh, we're checking for it up here. Okay, we're good. We're good. Okay. So we don't need this one technically. This can just be an else. So type in 90, we get an A. 80, we get a B. 70, we get a C. These are the edge conditions. 69, D. 71, C. 110, bad values, bad input. -10, bad input. 0 is another edge case. F. 1 is another edge case. You see how I'm testing it? I'm hitting all the different boundaries for the if statements. 1 above, 1 below, in the middle, big number, small number. Now I'm confident my code is correct. Okay. Always compile your code constantly. Always test your code constantly. And then after that, you're like, all right, I feel pretty good about this. You know, I feel pretty good about this. And you can actually codify. You can actually write down your tests. And that's something we'll cover more later. But it's very common practice in big companies these days to write your tests down. Like if the input is 80, the output should be B. If the input is 100, the output should be A. If the input is -10, the output should be error, or whatever. Right? And you write all these. It's like the input tester that we do, right? Like when you do the input tester, it feeds an input and it checks your output. And so a big part of being a programmer these days is writing those test cases. Writing, this is the input, this is the output, this is the input, this is the output. And then when you they sometimes do nightly testing, right, at Microsoft. Like, they might have thousands and thousands of tests, right? And so what they do is, like, they go home for the night, and then overnight, their data center will run all of these tests on their code and make sure that it's passing everything so that you didn't break something along the way. Okay, this is what it should look like, though, when you get all your code correct. All right, so yeah, just final words on checking for errors. Never assume that your user is going to give you the value you're looking for. Assume always that your user is stupid or malicious, even if it's you. Might be unintentionally malicious, but they might accidentally type in a semicolon and explode your server. And that person might be you, right? Every time you do input, vet the input. Okay. Every time you see a CN statement, you should think to myself, what could go wrong here, right? What could possibly go wrong with this? And with integers, floating point numbers, squirrel, any string will cause it to break, and you have to think about the actual values themselves. Is the value too low, value too high? With doubles, doubles are a little harder to break because they can take decimals. So we CN into F and C out F. Say if an error occurred, that's what if not CN means. If an error occurred, C out, error. Quit. Not yet. So if we type in 8.1, so if we type in 8.1, we get 8.1 back with a end line. Thank you very much. This is why you test your code. Even for something simple, test your code. Test your code. Test your code all the time. What if we type in -10? We get -10. All right. What if we type in 0.0123? 0.0123. Cool. What if we type in 0.123456789? Yeah, we're only getting, what is that, 8 sig figs? Do you guys know how to change the significant digits? This is something that comes up on your current homework assignment, actually. I have a minute. So you see out fixed to set it to fixed point, fixed decimal point, basically. And we do set precision to like, I don't know, 20 or some ridiculous number like that. And so if we type in 0.123456789, 10, 11, 12, 13, 9, you can see that the double is accurate out to, was that 10, almost 20 digits, right? Pretty good. Like, doubles have a pretty good precision on them. Usually that's about all you need. 20 digits of precision is enough to let you hit Mars within a centimeter of accuracy. Like, you're not going to hit it with a centimeter of accuracy. So, like, it's, yeah, it's probably more precision than you need if you were to shoot a gun. 20 sig figs of accuracy is like, yeah, probably more than you need because, just error is, in the physical world is going to be bigger than the code error. But if we do this with a float, 0.123456789, 0.123456789, you can see that with a float, we got our first error on the 10th digit, 9th digit. Yeah. So floats have about half the precision of a double. In fact, that's why a double is called a double. It's got double the precision of a float. Are there such things as half precision floats? Yes, but I don't think they're standardized in C++ yet. That's actually a good question. Half precision floats are actually pretty modern, which you would think's weird, right? But there you go. Half precision floats, C++. Implementing it. Float 16. C++ 23. Yeah, okay, there we go. There we go. All right. It's a half precision. There we go. Stood float. All right. There we go. Let's see if this is out yet, because this is the year 2023. Stood float. Let's go. All right. Nope. Sorry. What about float 64? Nope. So, not out yet. Come back later. Maybe, actually. Let's just double check that. Let me just double check, see if G++ will handle it. No. Yeah. Sometimes G++, like Clang and G++ are two different compilers we have, and they have different parts of the C++23 standard implemented in their standard libraries, but it looks like neither of them do. There might be some extensions for it. I can look around, but yeah. You would find with a 16-bit float that you would have, you know, half the precision of half the sig figs of a float. So let's compile this again, get it working again. Did I break anything? Nope. Okay. So what about this? Is this a valid float? We have one vote for yes. Anyone else want to take a gamble? Is this a valid float? No? No, those are the two options, so. It is. It is. Why is 8E5 8 with 5 zeros after it? No, because you're a hater? What if I typed in 1E3? Then I get 1 with 3 zeros after it. It is exponential notation. This is scientific notation. So I could do 1E negative 8 and get a number. Look, error, right? This is one of the reasons why we don't use floating point numbers unless we have to. Okay? Errors are endemic to all floats and doubles. So I said, give me a 1 with 8 zeros before it. Remember, floats don't have that many significant figures. If I go 1E negative 4, still not 0001, right? Still off. Okay. And you can see it's pretty accurate, but it's 1-ish. You know what I mean? It's like 1-ish to the negative times 10 to the negative 4, right? But it's not 1. It's 1-ish times 10 to the negative 4. You have to always be careful with floats and doubles. Anytime you use double equals with floats and doubles, you should have a nervous feeling inside of your heart, because there is absolutely no guarantee that the number that you think you have, you know, if f equals 0.001, see out, yay. Not a yay. 4 zeros and a 1. 4 zeros and a 1. Not the same number. Didn't compare. You know, anytime, anytime you see a double equals with a floating point number, you should have this feeling of like uncertainty, anxiety, and dread within your soul. Okay. Yeah, it's not a random letter. The E is exponent. It's the 10 to the whatever. Right. And so anytime you see a warning in C++, really pay attention to it, because it's there for a reason. This is valid C++, but the compiler is like really strongly trying to tell you, like, listen to me, you know, like, this is always false. Constant cannot be represented. You will never be able to represent 4 zeros and a 1 in IEEE floating point format. You're not going to get this, is what it's telling you. And so pay attention to it, because, you know, and if you don't know what it means, like, hey, how should I fix this? Ask on the Help Center. Okay. Anytime you get a warning, you don't understand it, there's probably a really good reason why there's a warning. The worst thing you can do is just be like, I'm just going to ignore it. Look, it's telling me how to turn it off. If I turn that off, G++, main.cc. G++ isn't even a warning. Clang++, it's giving me a warning. But look, it's telling me how to turn it off. What was it? No literal range. There. You turn it off. See, no problem. I can shut it up. The problem has now gone away. Yeah, don't do that. Some of the warnings are not super important. Like, what was it warning about? Unused. Oh yeah, unused variable age. Like unused variables, I usually don't care about. Unused parameters, I don't care about. A lot of times it's just because I'm writing code, I just haven't gotten around to like using them yet. But like, yeah, I mean, fair enough. Like I deleted all the stuff related to age, and I forgot about it. I left it in. So yeah, that warning was actually useful there. And I'm like, oh yeah, shoot, I did forget to take that out. So yeah. Normally I have that warning turned off because usually I know what I'm doing, and if I make a variable, I'm just going to use it later, and I just haven't gotten to it yet. So it's just, unused variables are like the least important warnings I've determined. Okay. So what else? What if we have negative nan error? Nan error. What if we have infinity error? What if we have 0.01? Yep. So floats are a little bit harder to break than ints, but they can still break if you type in squirrel error. Okay, you guys with me on this? Oh, maybe I'll leave it in. It's a good warning. All right. Yeah. So usually when you do floating point comparisons, you will do something like this. You'll say if x minus that, and you wrap parentheses around it, is less than like epsilon, right? Epsilon. Make it float epsilon equal to 0. So, yeah, something like that. Then see how you. So in other words, what you're doing is you're saying if the floating point value is close to 0.00001. You guys understand? So this is how you do comparisons with floats. Like, no joke. Like, double equals should always make you feel fear and anxiety and dread with floats, with doubles. The best way of doing it is you subtract two floats from each other and you say, hey, is the difference close to 0? And you can set epsilon to whatever tolerance you want. That makes sense? So if we type in 1 now, yay. Okay. It's close. It's close enough, right? And you can tweak epsilon to your application's particular needs. All right, but that's this is something that like in CSI 26, like students will it trips them up like later in their careers because you learn it now, you're like, oh, that makes sense, and then later on, like they're doing some mathematical scientific simulations, and then they're like, hey, is the float equal to this number? And then it never hits it. Like it might go from like 24 to 25, you think, but it actually goes from 24 to 25.01, and it isn't exactly equal, and it will, then the program runs forever because it was supposed to stop when it hits 25. It didn't hit 25. It hit 25-ish, but not exactly. And I'm speaking from personal experience. This has burned me many times. So just be careful. Don't use double equals with floats. Okay. Scientific simulations are a lot of fun. By the way, I did that professionally for a number of years. And it's, they use floats and doubles extensively, but you just have to be aware of the limitations of them. There's always error in the computation. You can't use equality. Numbers will sometimes turn into nans and infinities and things like that. The IEEE floating point format is kind of weird. You can have positive infinity. You can have negative infinity. You can have a signaling nan that kills your program. You have a quiet nan that doesn't kill your program. What is nan? Not a number. Like 5 divided by 0 is nan. Maybe. So, okay. So that brings our discuss. Oh, actually, there is one more thing. Sorry. Yeah, this is a. How many people here have heard of a computer game called Baldur's Gate? Baldur's Gate, video game, came out in the 90s. Heard of it? Yes, yeah. Baldur's Gate 3 just dropped 2 weeks ago, I think. You're playing 3 right now. Pretty good game, I think. What do you think, Espinoza? I think BG3 is like pretty darn good. But I played the OG Baldur's Gate 2, Icewind Dale, Planescape Torment, like all those like old school Black Isle games are just like some of my all-time favorite computer role-playing games of all time. And when I was in grad school, actually, for computer science, I was following the Baldur's Gate forums like religiously, like waiting for it to come out. I was very excited. This is 97-ish, I think. It came in 2000, so Baldur's Gate 1. 98, yeah. So it was 97 while it was still in development. I was following the development forums. And Fergus Urquhart, who is the producer, something like that, director, CEO, I don't know his exact title. He was kind of the guy that ran Black Isle Studios, people that made Baldur's Gate. He's like, hey, I'm looking to hire a programmer. And so I wrote to him, I'm like, hey, I'm down in San Diego. They're in Orange County. You know, I'm like, hey, love to work for you guys. And he's like, oh, well, I've always had really good experience with UC San Diego programmers. We're having a party on Friday. Why don't you come up and meet the people? And I'm like, that'd be cool. I'm like, but hey, I'm currently a junior. I've got like 1 more year to go before I finish. Is it, okay if I like wait a year? He's like, well, no. we kind of need to hire a programmer like now because the game's going to be out next year. I'm like, fair enough. And so I didn't go up and meet the people, and I still to this day kind of feel like even if I didn't take the job, it would have been fun to like go up there and like meet, get a tour of the place and stuff like that. But I kind of I kind of feel bad about wasting their time, like, hey, thanks for showing me around, bye, like I didn't want to be that guy. But I still to this day kind of like I could have. Maybe I could have gotten a job at Black Isle, and now it's Obsidian. Now it's part of Microsoft. These are the people that made Fallout New Vegas, which is one of I think probably my number one computer RPG of all time is Fallout New Vegas. Really wish they'd remaster that for 64-bit computers. But it's one of those what ifs in life. One of my friends was one of the producers on Fallout New Vegas. I brought her into, not a friend exactly, but kind of a acquaintance. I don't know, whatever you want to put it. But I brought her into my game dev class a couple years ago, and she spoke to my students here about game dev and stuff. Baldur's Gate. So Baldur's Gate had this short sword. I don't know if it's probably Baldur's Gate 2. It had this item called the Short Sword of Speed. Now, first of all, do you guys know what a short is? Not an int, but a short. You guys know what a short is. And so, ironically, it has nothing to do with a short sword. But do you guys know what a short is? It's like an integer. So integer x has 32 bits. And so the maximum number that can be represented by an integer is 2 to the 31st. Pull up the calculator. 2 to the 31st power, or 2 to the 31st power. Let's try that again. 2.1 billion and change. The smallest number is negative 2 to the 31st power, which is negative 2 billion and change. I think there's an off by 1 in there somewhere. A 64-bit number, which is called a long. This would be the long sort of speed. I joke. Long y equals 0. This has 64 bits in it. And so the biggest number that could be represented is 2 to the 31st power. 2 to the 63rd power, which is a very... No, try that again. Nope. Clear. What are you doing? Clear. Okay. 2 to the 63rd power, which is 9 quintillions. thousands, millions, billions, trillions, quintillions, petillions. I don't know. I don't even know how big a number that is. Like 9 pentillion, is that a number? I don't know. It's pretty big. It's not that big though. Like you can easily type that by just mashing your keys on the keyboard. Shorts though. Shorts have half an integer, so they are 16 bits wide, and so a short can hold a maximum value of 2 to the 15th power. Why is it 2 getting? Why are you doing that? Okay, 2 to the 15th power is 32,000. And so it ranges from roughly negative 32,000 to positive 32,000. Okay. So here's the deal. So the short sort of speed had a, I don't know what's happening here, had a variable that held how many charges it had. Every time you use the short sort of speed, it had some name. I don't remember the name now. Hey, Muya. Yeah. So Muya's at Microsoft now too. Yeah. I could have been a Microsoft person, Muya, but then again, you would have never met me because my life path would have involved having to drop out of college, and then I couldn't teach college, right? Like if I had dropped out as a junior, then no, I probably would have never looked back. If I had been working in the games industry, yeah, that would have been a completely different career path for me, and then then maybe you wouldn't be at Microsoft either because you're my student and stuff. Yeah. So anyway, one of those wonderful what ifs. So we've got this item, short sword of speed. What does it do? You got the short sword, you activate it, it hastes the party. Haste is one of these uber powerful buffs in 2nd edition D&D. It doubles all of your attacks and increases your movement speed. I think gives you a bonus on saves or something. Also in 2nd edition D&D, it ages you by a year. And so when I played pen and paper D&D, every time somebody casts haste, everybody would have to mark down, you have aged by 1 year. And so you'd have all these like 20-year-old adventurers that look like their grandparents, because every time you cast that spell, you like lose another year off your life. And so like a lot of people played elves because elves, who cares? Your age doesn't matter. There's no maximum age on an elf. So that was like the power gamer thing to do. But elves couldn't be raised dead, so anyway. So you have this short sword, and you can use it 6 times. Let's say that the value of the item, let's say we're going to hold the value in a long value is equal to charges times 1,000. So I'm going to change this to charges, because usually I don't know what the variable name should be until I use it. Okay, so charges is equal to 6. Value is equal to charges times 1,000, and we'll just see out value. Okay. So what do you guys think this is going to print to the screen? So the short sword of speed has 6 charges. The value of the weapon is proportional to the number of charges remaining. At full charges, it's 6,000. It's not. I think it was like 16,000, but just simplifying things here for you guys. So how much value does the short sword of speed have out of the box using these numbers, which are not exactly real? What do you guys think? 6,000. Yes, the value is not over 9,000. It is 6,000. Okay. So they actually were not holding charges in a short. They were holding it in an unsigned short. And so this one means it has a range from 0 to 65,536, if I'm remembering it properly. Let's see if Microsoft Calculator will work again. Muya, fix this if it doesn't. Okay, there we go. 65,536. Awesome. So, 35. So, yeah, you're right. You're absolutely right. Yes, because it's 0 to 2 to the 16th power is 65,536, but we include 0, so pull it down by 1. So, so they're holding it as an unsigned short, which seems reasonable. Like the charges range from 0 to 6. When the weapon hits 0, it breaks or something. No problem. But there's a twist to the story, okay? And the twist is there were these monsters in the game that when they hit you, they would drain charges from your item, okay? And they would drain a D4 charges. So if we're going to roll charges to drain, we'll do this as an integer, it doesn't matter. Charges to drain, And we're going to do this using a random die roll, which we'll learn more about random numbers later, but we'll just say rand modulus 4 plus 1. And we'll make it random. And so we are going to drain some charges off this thing. So we're going to say charges minus equals charges to drain. And so what is the value of the weapon going to be now? So I'm going to remove between 1 and 4. I'm going to roll one of those pyramid-shaped dice that I have over there. I'm going to roll it. I'm going to get a number from 1 to 4. And I'm going to subtract off that many charges from the short sword of speed. It's called like a Rumnavar. Start with an A, I think. I don't know. How much value is this weapon going to have now? Who can do math? It's going to be a range now, right? Because like we might lose 4 charges, we might lose 1 charge. What's the minimum? What's the maximum? I can sit here and wait until you guys come up with the answer. Still 6,000? Very correct. Yeah, so let's move that down there. Let's pretend this was the code all along. So yeah, so what is the value now? Big brain, Luke. Very good. Good catch. So what is the value of the weapon going to be? What is the minimum value? What is the maximum value? So the charges are 6. I get hit by this monster, which is called a Grajoir or something like that. I don't remember the name. And the Hedorgar, I don't know, some weird gas monster. It hits you, it drains a d4, charges off, which means minimum of 1, maximum of 4. Value goes down proportionally. What's the minimum value? What's the maximum value I can have now? Between 2,000 and 5,000. Good. Luke's the only person alive right now, I think. Okay. So, between 2 and 5,000. All right. What if we only had, I don't know, 4 charges? What is the minimum? What is the maximum? What is the minimum value? What is the maximum value? So it's got 4 charges. I could feasibly remove all 4, or I could only remove 1. If I remove all 4, the value is now 0. If I remove 1, there's 3 left. So it's worth 3,000. All right, good. There we go. We got a 3,000 eventually. All right. Now, my short sword only had 1 charge. So what is the maximum value of it now? 0? Let's find out. $65,534,000 gold pieces. It's an unsigned short. It cannot go negative. So when you take 0 and you subtract 1 from it, it underflows and it goes up to the maximum possible value. The maximum possible value for a unsigned short is 65,535. So it went from having 1 charge to somewhere around 65,000 charges. I don't know if it drained 4 or if it drained, if I run it again. Oh, look, that one was 0. If I run it again, you can see there's, small variance, 65 million. At this point, who cares, right? 1,000 GP at that point. I've got 65 million gold pieces now. And so then I had a dilemma, right? Because now I have a short sword that in every combat, I could activate it and double all of the attacks of my entire party, which was a melee-based party. For the entire game. For every combat, I could go into it. Haste. I could just haste, like, walking around the countryside. I'm tired of walking. Haste, just blow through the countryside at double speed. You know, haste. You know, normally this is a 6 charge item and you're done. I will never run out of charges when you have 65,000 charges. I can just tap that thing like over and over again and just go through the whole game in God mode. Or I could sell it. And this was something I agonized over for a really long time. Like for probably an hour, I just sat there like, I don't know. I could sell this for 65 million gold pieces and buy literally everything in Baldur's Gate. Every single item I could buy. The entire merchant stock I could buy. With money left over. But then I wouldn't have my Uber God item, you know? And so, infinite money exploit, right? And so I eventually did sell it. So I sold it, bought out all the stock. And then something funny happened. The vendor inventory reset the charges on it. And so I just bought the short sword back again. At a cost of, you know, using this model, $6,000. I think it was actually like 16 or something. And then I was like, cool. Then I burned the charges down to 1. Then I was running around trying to find these gas monsters, like, eat it, you know. Here, take off all of my other magic items, like this one, and whoop. And, you know, maybe it drops exactly to 0 and it breaks, you know. Okay, save scum, let's go back in. Eat it, you know, eats it, back up to 65,000 charges. All right, good to go. So I had my God tier item. I had literally every item in the game owned by myself. I completely bankrupted the economy of Baldur's Gate. Every single purchasable good was mine. They had tons of gold and nothing to spend it on. So I inflated their economy beyond recognition and destroyed their economy like Mansa Musa on his Hajj. So that's called an underflow bug. Okay. This is a underflow. Okay. You guys understand? If you go below the minimum value on an integer, it'll wrap around to the biggest. And if you go over the biggest, you get what's called an overflow. And you will wrap around the other way. Okay. So if we make a unsigned short named Bob, that's equal to 65,535, and we see out Bob, and then we say Bob, go up by 1, and we see out Bob again. You see that Bob turned into 0, right? 65,535 plus 1 is 0. Okay. This is a overflow. You guys understand? Overflow and underflow bugs are incredibly pernicious. They can be very hard to detect. I've encountered them in video games where like I got too much money in like Grand Theft Vice City and it reset my money to 0. It was really bad. It was Vice City if I'm remembering right. Yeah, like there was actually like I think a fairly low max money cap in it. It might have been like 2 billion or something like that, and you can overflow it back to 0. Yeah, it's simulating the IRS coming after you. I don't know. But yeah, overflow and underflow are serious bugs. And so the solution to it is just to make sure you never get near a boundary. And so, well, how do you avoid a boundary of 0? Well, don't use unsigns. Like, that's kind of a good advice, is anytime you're doing subtraction with an unsigned integer, you are risking opening the gates of hell. Like, it's like playing with that box from Hellraiser, right? Like, if you have 5 and you subtract 6, congratulations, 5 minus 6 is 4.2 billion. If you're working with unsigned integers, right? So if you're working with unsigned integers, you know, if you take charges to drain, and you like, I don't know, subtract 10 off of it. Charges to drain goes from 4 to 4.2 billion. 4 minus 5 is 4.2 billion and change. 4 minus 10, 4.2 billion and change. Unsigned integers are extremely dangerous to work with if you're doing subtraction with them. So it's kind of one of those things where it's like, it'd be nice, to make sure you can't have a negative number. Like if you're inputting your grade, just use an unsigned for your grade. But if you ever subtract anything with it, then you risk an underflow bug and having the thing. It's going to underflow charges. You guys understand? So my advice in general is to avoid using unsigned numbers. On not always, but like most of the time, if you're doing algebra with them, if you're doing subtraction in particular with them, don't use unsigned integers. Okay, they're there as an optimization thing, so you don't have to check against numbers less than 0, but they can be very dangerous. And the way they interact with regular integers is also dangerous. Regular integers turn into unsigned integers if you mix them. And so at -1, if you add, unsigned 4 and signed -1, you don't get 3. You get 4.2 billion and change. Actually, it'll probably overflow back out of it. Will it? Yeah, it probably will actually overflow back to 3. That's hilarious. But yeah, it'll overflow. It'll underflow and then it'll overflow, I think. I'm doing the math right in my head. But it's incredibly dangerous. So just avoid them if you can. Okay, so that is a little bit more detail than I usually give you guys on error checking, but these are all things to watch out for. Okay, and again, the solution is just to make your variables bigger than you need, right? So if your charges are going to range from up to 65,000, don't use a short, use an int. Just make sure you got more bits than you need. And if you're getting close to the $2 billion, $2 billion, like if you're in a video game and players could feasibly have $2 billion and they're going to overflow at 2.1, make a long instead. Long longs can hold up to 5 pentillion or whatever stupid sounding number that is. And if you need more than 9 pentillion or whatever, then there's what are called big int libraries. They're big int libraries that allow infinite precision integers that are out there if you need even more. All right, so I'm going to stop this recording and we're going to go over for loops in the last 12 minutes of class.